These are some examples of some Punnett square problems. We're going to start out with a problem about a monohybrid Punnett square. So this problem says curly hair is recessive and straight hair is dominant. A woman with curly hair marries a man who's homozygous dominant for straight hair. Predict the outcome of their children. So the first thing we need to do is choose a letter that we want to use. We're talking about a trait for straight hair and a trait for curly hair. So the way we decide on our letter is we're going to look at the first letter of the dominant trait, which is S for straight. So we're going to use an S, and since straight is dominant, we're going to use a capital S, and curly would be recessive, so we'll use a lowercase s. When you are choosing your letters and writing capital or lowercase, make sure that you show very clearly what the difference is between the capital and the lowercase so that you can tell the difference, because it can get really confusing if you can't. So the second thing we have to do is write the genotypes for the mom and the dad. In this problem, we have a woman with curly hair. And since she has curly hair, she has the recessive trait. And for her to have the recessive trait, she has to have two little s's. Because if she had a big S and a little s, then the dominant trait would take over and she would have straight hair. The man is homozygous, dominant for straight hair. So that means that he's going to have, first of all, straight hair, so he has to have a big S. And since he's homozygous, which means he has two of the same kind of letters, he's going to have another big S. So he is homozygous dominant with two big S's. Alright, it has to predict the outcomes for their children. So we're going to take our Punnett square, and we're going to write the mom's genes across the top and the dad's across the side. So we've got a little s and a little s for the mom, a big S and a big S for the dad. It's really important that you split up the alleles, so you're not going to write little s above the first column. You're going to write just one of those above one column and one of those above the other. So you're going to have just one letter above each column and beside each row. So when we cross the row with the column, we get big S, little s, big S, little s from here and here, another big S, little s, and another big S, little s. Okay, so this is the completed Punnett square. So we can see that there are 4 out of 4 chances that their offspring will be heterozygous dominant for straight hair. So we're going to go through and write the phenotypes for the offspring. This particular possibility has one dominant gene and one recessive. So because that straight hair gene is dominant, it's going to take over, and this outcome would have straight hair. Same here, we have the dominant gene that's going to overlap the recessive gene and take over, so this would also have straight hair. It's going to be the same because all 4 outcomes are the same. They will all have straight hair. Alright, so you can see that there's no chance for this mom and dad to have any kids with curly hair. All of their offspring would end up with straight hair. Alright, the last thing that we would need to do in a problem like this is write a genotype and a phenotype ratio. So let's start out with the genotype ratio. The genotype ratio is going to come from the letter combinations. We'll always start with the most dominant letter combination, homozygous dominant, and then we'll do the heterozygous dominant, and then we'll do the homozygous recessive. So the number of possibilities to end up with homozygous recessive traits, we don't see any of those here with 2 capital S's, so we're going to put 0. We're going to count how many of these we see. There's 1, 2, 3, 4. So there are 4 heterozygous dominant combinations. And how many do you see of little s, little s? There's not any here. So we're going to put a 0. So that's our genotype ratio, 0 to 4 to 0. And the order is very important. It's always going to start with the most dominant and end with the most recessive. The last thing we would need to do in a problem like this is write a phenotype ratio. And in a phenotype ratio, you're going to compare the traits. So here we have straight hair and curly hair. We're always going to put the dominant trait first and the recessive trait second. So to write our phenotype ratio, we would write how many of them end up with straight hair, which is 1, 2, 3, 4. And how many end up with curly hair. And there's not any there, so we're going to put 0. So our phenotype ratio for this problem would be 4 to 0. And that would be the end of that problem.